This exercise could be considered as a competition. The idea is that with the exercise you will receive an Adams command file describing a number of parts. The parts actually modeling a slew crane. Your task is to define all the constraints on the different parts in the slew crane, using the right constraints, using the right motions. Next, putting the crane on an icy surface, meaning a rigid surface without friction coefficient or with a zero friction coefficient, and then connecting the boom to the clamp, furthermore connecting the clamp to the load, so you can drive the crane to pick up the load from the start bucket geometries, move over to the target bucket geometries and drop the load at the target bucket geometries. We will show you a sample animation of how this has been done by former students. There we are. So here you see a cable connecting the clamp to the boom, the base starting to rotate using a certain motion. You have to define where to put the motion, so this is all for your brain power to investigate. In the end, when the load is properly aligned with the target bucket, you have to release the connection between the clamp and the load and drop the load in, so it also stays within those spheres over there. As always, the biggest word with simulation and modeling is crawl, walk, run. Please do not start with making the complete model, including all complexities. A first good start would be to fix the base to the ground, not having it rotate along and slide along, but try to get the maneuver of, or try to get the modeling components for the cable and the clamp connection, and do that first, and after that introduce the additional model complexity of the sliding along the surface and the ability to tip over. So let's start the model, open up Adams and load the command file called Slew Crane Start. Go through the model, investigate which parts there are, and step by step introduce constraints and linking the different parts, and finally defining the motion to get the load from the base to the target.